Yeah, well, so I'm going to talk about a paper that I've been working on for quite a while, about trying to wonder whether we can use HIIT as a method to improve bone mass. So I'm sort of split between a few different research areas, centres. So the Musculoskeletal Centre in Brighton, which is joint with the Medical School of Sussex, the Centre for Sport and Exercise Science and Medicine based at Eastbourne, and then the research group I'm in within the School of Pharmacy and Biomedical Sciences in Brighton. I'll gloss over that because most of you know me pretty well already. So like I said, I'm working in the School of Pharmacy, so it's a little bit different in terms of some of the stuff that we can do, which is nice, but it also makes doing hardcore exercise research quite difficult when you've only got one Monarch bike to work with and no other kit. So I'm going to talk today mainly about HIIT and how it interacts with bone, but I'm also interested in body composition, so how we can change fat mass and lean mass with different exercise interventions. And then one of the other reasons I'm here is to talk to Sam and Lex about some of the exercise adherence stuff that I've been generating some pilot data, and then some diabetes and glucose control stuff. So the first question we're going to ask is, how does exercise improve bone mass? And I'm hopeful that some of you might know. Any suggestions?
And this goes back to my undergraduate.
Yeah, way back.
Wolff's Law.
Wolff's Law. So what's Wolff's Law then?
The mechanostat.
Yes.
The torsion on the bone facilitates the adaptation process of building the bone.
Yeah, precisely. So Wolff's Law from 1892 tells us that bone responds to the load under which it is placed. So if you, like Tim Peake, you're in space and you unload the skeleton for a period of time, you'll lose bone mass. And when if you're exercising or putting high amounts of strain on it, high amounts of load, you increase bone formation and therefore lay down more bone material to respond to that new level of strain. So bone is constantly in a state of balance between being light and being strong. And this sort of developed the mechanostat theory in 1987 by Harold Frost up in Sheffield with some of his colleagues there, where they said that there's got to be a mechanism for how it senses this. And it's all to do with the osteocyte. So what the osteocyte does, and this figure's not very clear, apologies, is it senses the amount of load and strain that's being placed through the skeleton. So when we have a period of disuse, osteocytes die, they don't get stressed, they start to apoptose, and we get a decrease in bone stiffness to correspond with that decreased strain, and allow the bone to be light, so when we move around, we're not carrying around excess bone material that we don't need. On the other hand, when we're in periods of overload or periods of strain, osteocytes divide and we get more osteocytes being stressed, and we get increased formation, increased bone formation. And what this got coined was the customary strain stimulus here, which is basically, this changes depending on how active or inactive you are. So once you've stopped stressing the skeleton, it doesn't need to be any stronger, it'll plateau until you then need to stress it again. So basically, the more bone material you want to lay down, the more you have to increase the load or increase the amount of times you're loading the skeleton in order to cause adaptation. And this sort of led me to the idea that HIIT may have a potential benefit for improving bone mass, and I'll talk about that why a bit later on. So does anyone know what traditional exercise modes would be considered to improve bone mass?
Weight bearing.
Weight bearing.
Weight training, but that wasn't really,
Bit of resistance training. Impact.
Mainly impact.
Impact based. So
so
people thought impact weight bearing exercise was really important, and we've seen that in a whole host of studies here, where Vampire did a circuit-based program in 2005, and that loaded the lower limbs but not the upper limbs, and you can see here that we got increased bone in a whole host of regions in the hip, and these are the between group p-values above it there. So not only were they increased compared to baseline, that was different from the exercise group compared to the control, telling us that exercise, impact-based exercise, is positive for the bone in the hip, less so in the spine, because the spine wasn't being loaded. So this tells us that bone is very site-specific in how it responds to that mechanical load. So if you load the arms, as we see with tennis players, with more bone in their dominant arms, you're not going to get adaptations in the legs if you don't load them. So it's all about the site of loading, which is important when we talk about some of the results of the study we found, and thinking about actually, is something happening there which we can't maybe see due to a whole host of reasons. And what also appears to be important is how often you load the skeleton. So this is a really nice study done by Bailey and Brooke based in Surrey and Loughborough, where basically they did a single leg hopping study where you hopped 50 times a day for either 2, 4 or 7 days a week. And the hopping's really nice. It's because you've got the non-exercising control limb as acting as an internal control. And they actually showed that 4 and 7 days were not different, but they were both different from 2 and the control. So actually, up to a point, the more you do, the better. So it's about not only just loading the skeleton once a week, the more you can load it, the more positive impact you'll have. So interesting in terms of how much BMD is changing. And this was in the femoral neck specifically, and they didn't see it in any other regions of the hip. So it suggests that you've got to try and really load the limb the area you're trying to improve, rather than just focusing on one activity. So hopping, although a nice little example to show that we get a dose response, perhaps not optimal for improving bone mass. So what we decided was that because what we know about the number of load cycles and the strain that the bone needs to be placed under in order to cause adaptation, what we decided to do was to do a 6-week HIIT program. What we're actually doing is we're doing a 6-week HIIT program to look at body composition. So we're interested in how body composition improved following 6 weeks of training. But because we were doing DEXA scans to measure body composition, we thought, well, this exercise might actually add in a really nice way of improving bone mass. So what we decided to do was to add in pre and post DEXA scans on the hip and spine to see whether we could actually induce changes in the hip and not in the spine, because the spine is not being loaded, it's cycling, to see whether we could improve bone mass. Obviously, this protocol has limitations if you are thinking about it in terms of clinical populations. Are little old ladies for osteoporosis going to be able to do repeated Wingates? Probably not unless we start dosing them with caffeine. But perhaps it just shows that the principle is sound, and no one has actually done this, as far as I can find. No one has actually used this very short duration but very high intensity exercise to try and improve bone mass. So before we talked about that, we did show reductions in fat mass in the lower limbs and whole body region, minus the head, in our exercises here compared with our controls. You can see quite a large range in terms of absolute change in fat mass in kilos. But when we look at it in percentage fat, subtotal appears to be non-significant, but the lower limb and upper limb appears to be significant, suggesting that we are changing fat mass as a response to the exercise mode, but no change in lean mass, which we were sort of a bit surprised about, because we were expecting lean mass to improve and therefore have a positive effect on the bone as well, because we know that muscle mass and bone mass are linked in terms of how bone mass develops, because if you've got high amounts of muscle mass putting large amounts of strain on the skeleton, you're going to get stronger bones. But what we actually found was trends towards significance, a horrible term, I know, and something that we need to sort of work out how we can phrase this in the right way. But in bone mineral density in the femoral neck, and then in total hip bone mineral content and bone mineral area hip. So it seems like we are causing an adaptation in the hip, probably underpowered because we only had 18 people, so suggesting that we don't have enough people to observe this effect. But the fact that we're seeing it here in the hip and we're seeing no change in the spine makes us think that something is happening. If it was just random error in terms of my use of the DEXA, say my use of the DEXA operation was rubbish and it was just poor positioning, well, why would you see poor positioning in one scan but not the other?
Yeah, it wouldn't be random error anyway.
Yeah.
I mean, it would be a systematic way that maybe you change the way you scan them at the end compared to the
Beginning.
beginning and only in the
Exercise and not in the control. So it makes me think that this is not just random error, that there is something going on that we probably don't have enough power to detect. And unfortunately I don't have access to a DEXA scanner anymore, so I can't add some more people in. But it makes me think that because we're seeing it just in the hip and not in the spine, and just in sort of this area here in the femoral neck, makes me think that we're going to have some. We've obviously got some quite large variation again in percentage change from baseline. And maybe if you take this one out, then your mean drops right about down again. So it may be that we just got some artifacts of outliers, but it makes me think that there's something interesting going on.
Who did the analysis of the scans?
That was me.
Okay.
I did them all.
Because the only issue is that you may even subconsciously have some sort of bias, because obviously that was your hypothesis. Because what kind of worries
Oh no,
me
so
is the change in area. So that, you know what I mean?
So the scans were blinded for analysis. So I didn't know, when I analysed them, I didn't know what scans were what.
So you didn't train the people?
I trained the people and did the scan, but then did the analysis having
No knowledge of...
no knowledge of which group they were assigned to.
Okay.
So I basically had a list of scans, analysed them without the code on, and then got the code off and back afterwards. So it was blind analysed, which again, sort of the fact that we're seeing it just in this group here and not in the controls makes me suggest that actually is something happening there. And so we're sort of trying to frame this at the moment because it's interesting, I think. So it's currently under review in the International Clinical Journal of Sports Medicine as a short communication, just as say this is not world breaking. It's not going to say everyone who's got osteoporosis should start doing HIIT, but it does suggest that perhaps we can try and use a very short duration exercise, and it doesn't have to be load bearing.
Yeah.
And to try and see whether we can maybe improve both.
What concerns me is do you really think that you can induce, is there any evidence that you can actually induce with other interventions significant increase in bone mineral density in 6 weeks?
Yes.
That's my main. Okay.
Yes.
Because 6 weeks, if I remember well again, going back to 1989, really it takes about 6 months.
Yeah, so
to form.
a couple of meta-analyses published in 2013 said minimum of 24 weeks, minimum of 6 weeks, 6 months to have an effect. We've got some studies that have shown changes in bone mineral density in 6 weeks.
But with what?
With exercise intervention. They were trying to get a whole picture of the whole literature.
Yeah.
We're suggesting that perhaps it doesn't need to be as long.
Based on these.
Based on the other studies that have shown it in 6 weeks. So yes, and it may have been that we stopped it a bit early, and if we kept going for another 6 weeks and gone to 12 weeks, 3 weeks, we may have seen that those changes became greater.
So you think it's biologically plausible that you can get significant change in bone mineral density in 6 weeks?
Yes, I think so.
No. I mean, you're the expert. You know, if I go back to when I did my undergraduate degree, I would say, for what I've seen then, it wasn't biologically plausible. But maybe it is.
But the reason what suggests that this method might is because if you think about the load that's being placed on the skeleton in those long duration studies, is that the load is a lot lower than was being placed here. So what we're trying to do at the moment is sort of try and understand what's going on as we're trying to map force production in the thigh during Wingates with some accelerometer data in the foot to see if we can quantify the amount of strain that the bone is being placed under, in order to show that actually, yes, we can produce enough force in a bout of hit, and if we're doing enough of them, then we're going to see adaptation. And we're also going to, I'll talk about in a second, try and do some blood markers to see what's happening to bone formation in response to single bouts of hit. So if we can add that strain in. But what's interesting is these magnitudes of change are greater than have been seen in studies of longer duration. So studies of 12 and 24 weeks have shown smaller magnitudes of change than we've shown in 6. So it may be that, like I said, this one individual here, because that's one individual there, is skewing the data up, and that's a likely explanation. But interestingly, I want to see what happens when you add it to a bigger population.
Another question: did you do the stats on percent changes?
No. So we did an ANCOVA with baseline data as the covariate, and then analysed the difference between the groups on the raw data. Yeah. I had to teach myself how to do that to try and work out the best way of analysing the data.
That's the best way to analyse any data of this sort.
Because it's
false, but certainly not percent change is the worst way.
No, but yeah, because it's very inefficient, isn't it? It's sort of
It's wrong, actually,
statistically. And it means you're much more likely to find something.
It's fine to express it.
Yeah, so we basically expressed it as percentage change, but did it as on the raw data. Yeah, no, that was something that we had to make sure we did. So because the magnitude is greater, it makes me think that something is happening. I'm not pretending in any shape or form that this study is.
No, but it's promising.
I just think it's interesting more than anything. And the fact that we saw changes in the hip, I didn't show any of the spine data. The spine was no differences at all, and almost identical. Makes me think that because we're stressing the hip and not the spine, that we are using that mechanostat and we're trying to cause adaptation because we saw no change in the lumbar spine. So yes, we didn't get statistical significance. And if I'm being honest, one of the p-values is 0.56. So the fact that we've set this arbitrary cutoff at 0.5 means this is not significant. But interesting is perhaps the way I describe it. So what we're trying to do now is see whether HIT has potential to improve bone mass. So what we need are more studies looking at how HIT can improve changes in bone. I'm not the only person who thinks that high intensity exercise may be beneficial. This was 3 times a week doing 125% body weight reps. So they wore weighted vests and did 3 times a week for 12 weeks. And you can see here quite large percentage changes, again analysed the same way using ANCOVA, in lumbar spine and femoral neck bone mineral density in response to that type of exercise. So this is load bearing, but very high load. So I'm thinking that the high load is what's important, not necessarily the impact. And that's sort of where we're going. So what we're doing at the moment is trying to work out if we can, if there are changes in formation as response to a single bout of HIT exercise. So we're taking some baseline blood samples with blood samples an hour and 24 hours after a HIT bout, just 4 repeat Wingates, which is difficult enough. Taking some blood samples at this time point to see whether we can find some changes in formation in response to that type of exercise, potentially compared with just a control bout of not doing anything, but it all depends on how much money my master's student has in their budget to work out if we can do this. So this will hopefully give us more of an understanding in what's happening in sort of resorption and formation based on some markers here that have been identified as potentially quite important. And we're going to try and coincide that with the changes that we're seeing or the high strain that we're going to try and map using some EMG and accelerometer data to try and map the changes in both to see whether we are having high strain and that's perhaps impacting on bone formation. So I'll happily stand here and answer any questions that any of you might have about this or about HIT or about how maybe we might be able to do some interesting collaborations. We've got some very cool kit in Brighton that you may not have access to here that we might be able to sort of tap into. That's stopped, is it?